If you've ever used Spring Data JPA, you know that feeling. That little bit of magic. You write an interface, no implementation, and bam, it just works. But what happens when that magic breaks down? Well, today, we're not just peeking under the hood, we're going to take the whole engine apart, piece by piece, to see exactly how it ticks.
This is the core mystery, isn't it? We define something like a user repository. We extend an interface, but we never actually write a class that implements it. And somehow, it all works perfectly. So where's the actual code coming from? That's the puzzle we're here to solve.
And look, this isn't just about satisfying our curiosity. When performance starts to drag, or a transaction fails for no obvious reason, and trust me, it will, knowing this stuff is the difference between a 5-minute fix and an entire day spent pulling your hair out. It's about moving from just using a tool to truly mastering it.
So, to make sense of all this, we're going to use a simple metaphor, the JPA onion. We'll start at the very top layer, the one you and I interact with every day, and we're going to peel it back one layer at a time until we get right down to the core that's actually talking to the database. Okay, so this top layer, Spring Data JPA, this is our home base. Its main job in life is to save us from writing tons and tons of boilerplate code. Remember the old days of JDBC? All those repetitive try-catch finally blocks and managing connections, ugh. This layer just abstracts all of that mess away behind those clean, simple repository interfaces we know and love.
Now, let's peel back one layer. Here we find JPA itself, the Java Persistence API. Now, it's really important to get this straight. JPA is not a tool. It's a blueprint. It's just a specification, a set of rules and interfaces like Entity Manager that lays out how persistence in Java should work. It gives you the map, but it doesn't give you the car.
And this is the car. Hibernate is the engine that actually brings that JPA blueprint to life. It's the most common JPA provider out there, pretty much the industry standard. This is the real workhorse. It's what generates the SQL, manages the session cache, and does that cool, dirty checking thing. You know, where it automatically figures out what you've changed in an entity and saves it for you.
And finally, at the absolute core of our onion, we hit JDBC. This is the bedrock. Everything else we've talked about sits on top of this. It's the fundamental, low-level Java API that takes the SQL that Hibernate just built and actually sends it over the wire to the database. It all comes down to this.
Okay, so we've seen the layers, all the way from our code down to the database. But that still doesn't quite answer our original question. If we only write an interface, where does the actual object come from? Well, the secret ingredient, the key to the whole magic trick, is a concept called proxies.
So what on earth is a proxy? Think of it like a stand-in or a middleman that Spring creates for you on the fly. When your application starts up, Spring doesn't generate a .java file for your repository. Instead, it creates a fake object right there in memory that pretends to be your repository. It intercepts every single call you make to it, which allows Spring to weave in all sorts of cool behavior, like transaction management, without you having to write a single line of it.
Let's walk through the whole flow. First, when your app boots up, Spring scans your class path, looking for any interfaces that extend its repository. Second, for every single one it finds, it creates one of those dynamic proxy objects. Now, here's the crucial part. When your code calls repository.save, you're not actually calling your code. You're calling the proxy. And finally, that proxy intercepts the call, wraps it in a database transaction, delegates the real work to the underlying JPA provider, and then commits or rolls back the transaction. And that, right there, is the magic.
Okay, so now that we get how proxies work, let's talk about a classic gotcha that trips up even seasoned developers. It has everything to do with how these proxies work, or more importantly, how they can be accidentally bypassed.
So here's the scenario. You've got a method in a service class marked with @transactional, but then you call that method from another method inside the very same class. This is called a self-invocation. Because you're making an internal call with the this keyword, you're not going out through the proxy, you're just calling the method directly. And if you bypass the proxy, you bypass all its transactional magic. No transaction gets started, and you're left with some really confusing bugs. It's a super common pitfall.
All right, let's switch gears and talk about performance and resources. The way JPA manages its core components isn't random. It's designed for efficiency. And it's vital to understand the difference between two key players here, because one is super expensive to create and the other is basically free.
This table really lays it all out. The
The Entity Manager factory is the big, heavyweight component. You only create one of these for your entire application when it starts up. It's totally thread-safe and holds all the parsed metadata about your entities. The Entity Manager, on the other hand, is super lightweight and cheap. You get a brand new one for every single transaction, and it is absolutely not thread-safe. So think of the factory as the permanent, heavy-duty machine tool, and the manager as the disposable blade you use for just one cut.
So with all these pieces in our head, the layers, the proxies, the heavyweight and lightweight components, how does it all come together when you hit run on your Spring Boot app? Let's quickly walk through that startup sequence.
It all kicks off with configuring the data source, which is basically your pool of database connections. Then that big, expensive Entity Manager factory gets built. This is where Hibernate goes and scans all your entity classes. Next, Hibernate might validate your schema, checking if your Java classes actually line up with your database tables. And finally, Spring works its magic, creating the proxies for all your repositories, making them ready to be injected into your services. Only then is your application actually ready to handle requests.
And that really brings us to the main takeaway here. It's one thing to use a powerful tool like Spring Data JPA. It's another thing entirely to truly master it. Once you understand the machine, how it's built, and how it runs, you know exactly which levers to pull and which knobs to turn to tune it for maximum performance and reliability.
So just as a quick recap of some key terms from our journey today, we've got ORM, which is the whole concept of mapping our Java objects to database tables. We've got the dialect, which is what tells Hibernate how to speak the specific flavor of SQL for, say, PostgreSQL versus MySQL, and that critical warning about DDL auto. Please, whatever you do, never use update in production. It's a recipe for disaster.
So, we've done it. We've peeled the onion, we've uncovered the secret of proxies, and we've walked through the entire life cycle. You've seen the machine. So my question to you is, now that you have this knowledge, what's the first thing you're going to look at differently in your own application? What part will you tune first? Thanks for diving deep with me today.